In this video, we're going to talk about formal charge. So formal charge is the way for us to keep track of electrons. We can think of it like that. So sometimes there's a molecule and it has a charge on it, and we just put the charge outside of brackets, but we don't know which actual atoms have that charge. By assigning formal charge to each individual atom in a molecule, we can tell where the electron density lies in that molecule. So to calculate your formal charge, what you're going to do is take the valence of whatever your atom is and subtract from it, and I'm going to put this part down here, the number of non-bonding electrons. So those would be like lone pairs of electrons, plus 1/2 of the number of bonding electrons. So we're going to treat bonding electrons as though they're shared equally between the two atoms that the bond is between. So let's begin with a small molecule here. Make my electrons a little bigger there. Okay, so I've got this simple molecule. There's 2 hydrogens on there. My hydrogen can only make 1 bond, and it is, so I'm not going to worry about formal charge for that, but I will calculate formal charges for my carbon and my oxygen here. So for the carbon, the valence of carbon is 4. That's something you want to become familiar with immediately because we're going to be using carbon all the time in organic chemistry. So I would expect a neutral carbon atom to have 4 bonds. I'm going to subtract from that the number of non-bonding electrons, which in this case is 0. There's no lone pairs of electrons or any unbonded electrons on carbon, so that's 0. And then I'm going to add to that 1/2 of the number of bonding electrons. That carbon atom has 3 bonds. In those 3 bonds are 6 electrons, right? Because there are 2 electrons per each bond. So I'll take 4 minus 3, and that equals +1. So the formal charge on my carbon atom is +1. So I'll put my positive right on the carbon atom. That tells me that it is electron deficient. On my oxygen, the valence of oxygen is 6. I would expect a neutral oxygen atom to have 2 bonds and 2 lone pairs. I'll subtract from it the number of non-bonding electrons. It has 3 lone pairs on it, so that's 6 total non-bonding electrons, plus 1/2 of 2, because it has 1 bond to the carbon. So I'm subtracting 6 minus 7, that equals -1, so the charge on my oxygen atom is negative. So using formal charge, I can keep track of where the electron density lies in the molecule. In this case, the carbon atom is positive and the oxygen atom is negative, and those charges are going to have a lot to do with the reactivity of a molecule. So let's do one more example. Okay, so again I have hydrogen atoms. In this case, they're all terminal, they all have 1 bond, so I'm not going to look at them, but I will look at my nitrogen, my fluorine, and my carbon. We want to be able to quickly look at carbon atoms, nitrogen, oxygen, and the halogens and know what their charge is. So you can begin by doing formal charge, and that will always give you the right answer, but as we go along, it's very important that you quickly can recognize whether an atom is charged or not, since we work with so few in organic chemistry. So let's start out with that nitrogen atom. The valence of nitrogen is 5. I subtract from that the number of non-bonding electrons, which in this case is 0. There are no lone pairs on that nitrogen, plus 1/2 the number of bonding electrons. There are 4 bonds, so 8 bonding electrons. So that nitrogen has a positive charge on it, so I'll come up and I'll draw that positive right next to that nitrogen. For my carbon, again, the valence is 4. It has a lone pair in this case, so there's 2 non-bonding electrons. It has 3 bonds, so there are 6 electrons in those 3 bonds. So this carbon atom has a charge of -1. And then lastly, we'll look at our fluorine. Fluorine and the other halogens have a valence of 7. Fluorine is in the second row, so it can't break the octet rule. So we have 7 minus 6 non-bonding electrons from those 3 lone pairs, plus 1/2 of 2, because it has 1 bond to the carbon. So that is 0. So that fluorine doesn't have any charge at all. We could put a 0 next to it, but we don't have to. In this case, we have a nitrogen with a positive charge and a carbon with a negative charge. The overall molecule is neutral, but again, the reactivity of molecules has a lot to do with what their charges are. In chemistry, opposites attract, and we're going to use this again and again as we go forward.